10.3, right triangle trigonometry. All right, so everybody has learned SOHCAHTOA. Another way to memorize the trigonometric functions is this picture right here, which describes some old hare came a-hopping through our alley. So this is where we get the SOHCAHTOA. The important thing is that you realize that sine is really opposite of hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. And here we have all of our inverse trig functions. And I'm going to reverse the order of these two, because I think cosecant should go first, because that is the inverse of sine. So sine's inverse is cosecant. As you can see, opposite over hypotenuse is sine, and cosecant is hypotenuse over opposite. Cosine is adjacent over hypotenuse, which reciprocates to hypotenuse over adjacent. And finally, tangent is opposite over adjacent, and cotangent is the inverse of that, adjacent over opposite. The angle of perspective is the angle that determines what sides are opposite and what sides are adjacent. So here is the angle of perspective. And as you can see, it is directly opposite the opposite side. That's why we call it opposite. And adjacent actually means next to. So as you can see, this side is right next to the angle of perspective. Hypotenuse is also right next to this angle. However, the hypotenuse is the hypotenuse because it's the longest side of a right triangle, the one opposite the 90-degree angle. So what would happen if we moved the angle of perspective? Let's go back over here, and let's just take this angle of perspective and move it up here to the B. Well, then this would be the opposite. Opposite would be AC. Adjacent would be BC, and the hypotenuse would stay the same. A couple other vocab words: angle of elevation is important, and angle of depression. Example 1. So here we have a right triangle with two sides given. We're missing one of the sides. So in order to find the value of all 6 trigonometric functions, you need to find that third side. So we're going to use the Pythagorean theorem. And as you can see, the answer is 8. That's the missing side. You could also memorize your Pythagorean triples, 8, 15, 17, just like 3, 4, 5. Okay, then we go through, we say, all right, sine is opposite of hypotenuse. Opposite is 15. Hypotenuse is 17. Cosine is adjacent over hypotenuse, 8 over 17. And tangent is opposite over adjacent, 15 over 8. All right, now for the inverse trig functions. The inverse of sine theta is cosecant theta. The inverse of cosine theta is secant theta. And the inverse of tan theta is cotangent theta. And these can all be written as the reciprocal of these original functions. And reciprocal means you take the ratio and you invert it. So 15 over 17 is 17 fifteenths, 17 eighths, and finally 8 fifteenths, 8 over 15. Okay, so this one is the you-do. It's a 6, 8, 10 triangle. There's your Pythagorean theorem. And notice that we reduced the fraction for each of these. So 8 over 10 becomes 4 fifths, 3 fifths, 4 thirds, and now for the cosecant, secant, and tangent, we have the reciprocal of all of these ratios, 5 fourths, 5 thirds, and 3 fourths. Okay, so here is a word problem where we need to find the height of the tree given the length that a person stands, the distance that a person stands from the base of the tree with the angle of elevation of 70. So we need to realize that if this is our angle of elevation, this is the adjacent side is 23 feet, and the opposite side is unknown. We use h. So what trig function uses opposite and adjacent? Tangent does. So tangent of theta equals opposite over adjacent. We take 70, we plug it in for there, for theta. H stays h, that's the unknown side that we're solving for, and 23 goes in for adjacent. We multiply both sides by 23, and our answer is 63.2. Here's the u-do, and as you can see, the angle of perspective, we have opposite and hypotenuse, which is sine. So we plug in sine of theta is 4 over 10, and because we are trying to solve for theta, we need to get rid of sine. And the way we undo sine of something is to use inverse sine, also known as arc sine. So you inverse sine this side, you inverse sine this side, and we get to that by clicking second sine on the calculator, and that gives us theta by itself equals sine, inverse sine of 4 over 10, which is 23.6. Find the value of the missing side, round to the nearest 10. Alright, so previously we found the missing angle, and now we're finding the missing side. So here they give us the angle of perspective, the opposite, and the hypotenuse is what we're solving for. So we're going to use sine because sine of theta is opposite of hypotenuse. So we plug in sine 23 equals 9 over x. Here's where I recommend that we cross multiply. We're basically just putting sine 23 over top of 1. And when you cross multiply, you end up with sine 23x equals 9. And we want to treat this like it's a single quantity, which it is. So we divide both sides by sine 23 to get that x by itself. So now we have x equals 9 divided by sine 23. And plug it in your calculator carefully. The answer is 23 units for the hypotenuse. So here we have number 6. What is the angle of elevation to the top of the 18-foot flagpole measured from a point 8 feet from the base of the pole? So this is similar to the tree problem, except now instead of finding the height of the tree, we're actually looking for the angle of elevation. So we're going to use, because it's opposite and adjacent, we're going to use tangent, because tangent of theta equals opposite over adjacent. So we're going to plug in tan theta equals 18 over 8. And to get that tangent to get the theta by itself, we have to undo tangent. So we're going to do inverse tan on both sides. And we end up with 66 degrees. Okay, last question. Here we're going to solve for angle K. So because they give us the adjacent and the hypotenuse, we're going to use cosine. Cosine of theta equals adjacent over hypotenuse. We're going to plug in 5 for adjacent and 6 for hypotenuse. Now we have to undo cosine theta by using inverse cosine or arc cosine. So once you plug that in the calculator, you end up with 33.55. Now many people are tempted to putting down 4 as the answer. However, the question asks, what is the measure of angle K to the nearest minute? You must realize that a degree is broken down into 60 minutes, and each minute is broken down into seconds. So we have to use the calculator feature DMS, which stands for degree, minute, seconds. And the way you get to that is by clicking second, apps, which accesses the angle, and you go down to option 4, which is DMS. So after you have your answer, you click DMS, and it gives you the degrees, the minutes, and the seconds. So the answer is actually 1. Good luck to you.